Find the derivative of y equals the square root of cosine 8x over sine 8x plus 4. So y here is the square root of an entire expression. And that entire expression itself is a quotient. Cosine 8x over the sine of 8x plus 4. And if you pay attention to how this is read off, it gives you a hint at how to take the derivative. We have the square root as the outermost function here of what is a quotient. And that means we're going to work with the root first, take its derivative, and then the derivative of the inside for the chain rule will be a quotient rule. But before we do any of that, let's rewrite the square root as the entire inside expression, which is a quotient, to the first power, second root, 1/2 power. We can see that 1/2 power is the outermost function, so the derivative y prime or dy dx will be, starting with the power rule, bring the power down, 1/2, leave the inside alone, cosine of 8x divided by the sine of 8x plus 4. Subtract 1 from the power, I will call that 2/2. And now we need to multiply by the derivative of the inside to complete the chain rule. The inside being the inside of the power, and the inside of the power is all of this. The derivative of the inside will be a quotient rule because it's a quotient. We start with the derivative of the numerator. The derivative of cosine of 8x is negative sine of 8x, and then times a to complete the chain rule for that. Derivative of the numerator times the denominator left alone, sine of 8x plus 4, minus the numerator left alone, cosine of 8x, times the derivative of the denominator. Derivative of sine of 8x is cosine of 8x times an 8 to complete its chain rule. And then the derivative of 4 is a 0. All of this is divided by the denominator quantity squared, and this entire thing is multiplying everything else. Okay, so y prime, or dy dx equals 1/2. We have the cosine of 8x over the sine of 8x plus 4 to the 1 minus 2 negative 1/2 power. And we have a negative, I'll put the 8 out front. I have this 8. I'll move that out front there. Negative 8 sine 8x times sine of 8x plus 4 minus, and then this second term we have an 8 that everything's multiplied. We'll move that out front with the negative, so we have a negative 8. And then we have a cosine times a cosine. We can call that cosine squared of 8x. All of that over the denominator squared. So sine of 8x plus 4 squared. We're not going to do anything with that. Okay, my next step, I have a couple things I'm going to do here. First of all, this quantity to the 1/2, we can break it up into the numerator to the negative 1/2. And the denominator to the negative 1/2 separately. That's always possible. When you have a fraction to a power, you can break up each of the numerator and denominator to that same power. In the square brackets, I'm going to distribute this into here. So I will have a negative 8 sine squared 8x. I will have a negative 32 sine 8x. And I have a negative 8 cosine squared 8x. All of this over the sine of 8x plus 4. Quantity squared. What I'm going to do with this, though, is that sine of 8x plus 4 quantity squared in the denominator, instead of writing it as a 2, we can rename it a 4 halves. Now, you might wonder, why do we do that? Well, we have fractions multiplying each other. And we multiply the fractions. We're going to multiply all the numerators. That's all this stuff multiplying each other. And we can multiply the denominators, and that's all this stuff multiplying each other. And we're now going to do that, so we can write this as a single fraction. And in the numerator, I have a 1 times a cosine of 8x to the negative 1/2. Well, 1 times anything is the same thing, so I'll just write cosine of 8x to the negative 1/2. And then I have that entire expression that's all of this stuff, which I will rewrite. But what I'm going to do is I'm going to move that cosine squared term, that's the third one in the list, I will write it second. So you have to keep it subtraction, but you can rearrange the order in which things are being subtracted with each other. And then the negative 32 sine 8x I'll write as the third term. The reason I did that is we have a sine squared and a cosine squared, and we have a Pythagorean trig identity for that. As long as they have the same coefficient, whether they're both positive or both negative, it doesn't matter. They're both -8s actually here for their coefficients. We have the identity. That -8 can factor, and we will get the identity for those. So I'm preparing it to make the identity happen. Now back to the denominators, multiplying those. Now what I have in the denominator, I have a 2, so let's not forget that. So I have a 2 down here. And I have prepared these to multiply. They have the same base, and now we can add their exponents. And that's why I wrote that square power as a 4 halves, because we can add negative 1/2 plus 4 halves. Negative 1 plus 4 is a 3 halves. So all of that is sine of 8x plus 4 to the 3 halves power. Okay, now in my next step, I'm going to move that cosine of 8x that's to the negative 1/2. That can now move to the denominator and be to the positive 1/2. So I will no longer have it in the numerator. So I can kind of maybe write the denominator first here. It might be a good idea to do that. So I have a 2. I have the cosine of 8x, and it will be to the positive 1/2. And I have the sine of 8x plus 4, and it will be to the 3 halves. And back in the numerator, I have just this expression left over. And what I'm going to do is factor in -8 just from the first two terms. They are the sine squared 8x and the cosine squared 8x. And if we factor out a -8 from both of them, they both become a positive 1 for their coefficients. I'm not going to factor it from the other term, though, because it's not part of the identity. But you can see we have sine squared plus cosine squared. As long as they have matching phases, this entire thing will be a 1. And we can now replace it with a 1. And so y prime or dy dx will be a -8 times 1 minus 32 sine of 8x, all divided by 2 times, we have a cosine of 8x to the 1/2. That means the square root to the first power, so the square root of cosine of 8x. We can write it that way. And then we have the sine of 8x plus 4 to the 3 halves power. Now in the numerator, we actually have a common factor of a -8. So I will factor that out, and that will leave us with a +1 and then a +4 sine of 8x over the 2 square root cosine 8x, and then the sine of 8x plus 4 quantity to the 3/2. And we actually will be able to cancel down the numbers a little bit because we have a -8 in the numerator and a 2 in the denominator. You have to wait till you factor, but once you factor, which we did, that -8's multiplying all the numerator, we can cancel down this 2 with this 8 to give us a 4. So we have a -4. We have a 1 plus 4 sine 8x, all divided by the square root of cosine of 8x times sine of 8x plus 4 quantity to the 3/2 power. There's maybe one more thing that we can do. This is one way the derivative may be written. But this 3/2 power here, this could be written as square root of quantity cubed. So let's look at that version as well, and that may be another way to write it. Oftentimes this left is just the 3/2 power. But because we already have a square root in the denominator, there's a possibility to combine those square roots, so we'll look at that optional way of writing this answer. The numerator we're just going to keep as is, so -4, 1 plus 4 sine of 8x. We're not going to do anything with that. It's all about this denominator, and we have the cosine of 8x under a square root, and we'll have what is a sine of 8x plus a 4, and it's to 3/2. Now what that means is the 3 power and second root, or square root. And so we can write it this way, and we can actually combine those square roots together under a single root when you have roots multiplying, as long as they're matching roots. They're both square roots. It's possible to combine them under one square root, and they're multiplying each other. Cosine of 8x, and then times the sine of 8x plus 4 quantity cubed. So there's an alternative way to write the derivative. Either version's good, but that's our derivative y prime or dy dx.